In this chapter, we will see how the database files are handled in RPG 400. As you know, there are two types of database files on the AS400, externally described and program described or fixed format. With externally described files, the field definitions are stored along with the data in the database files itself. These definitions are brought into the program at compilation time and need not be coded in the application program. Program described files are defined to the system at the record level, and the RPG 400 program that use the file must break up the record into fields. One important point to mention here is that at the program level, there is no distinction between a physical file and a logical file. Both are defined and used in the same way. In Chapter 1, we saw how an externally described file is defined and used in an RPG program. Let us now see how to use program described files. When using program described files, we have to make a few changes to the program. First of all, we code the file specifications. In the F specification, we write an F instead of E in column 19 to indicate that it is a program described or fixed format. In positions 24 to 27, we need to code the record length for program described file. For the customer file, we code a record length 63, and for the printer file, we will use 132 as this length is supported on most printers. Remember, this value has to be right justified. For program described files, we have to include an input specification through which we will define the fields in the record. We begin by identifying the input files. The name of the file is entered in positions 7 to 14. Then you have a sequence entry in columns 15 and 16, which are used to specify whether the order of records in the file should be checked or not for files containing multiple record formats. When sequence checking is not applicable, you can code any two alphabetic character here. Next, we describe each of the field in the record. In positions 44 to 47, we specify the beginning positions of the field within the input record. The ending position of the field is coded in positions 48 to 51. For a 1 byte field, the from and to locations will be identical. Remember to make these fields right adjusted. Position 52 is used to specify the decimal position in a numeric field. For character fields, leave this column blank. For integer data, enter a 0 for decimal positions. Positions 53 to 58 are used to hold the field name. It should be left adjusted. Next, we need to add the output specifications. One set of specifications is required for each program described output file defined on the F specifications. Here, we need to specify the format of the output records in case of database files or output lines in case of reports. Our output report has three different types of line to be printed. Two heading lines that are printed at the top of each page and one detail line for each record in the input file. Hence, we need to specify three different record formats. We will have one line of output specifications for each of the record formats that will identify the records. Positions 7 to 14 are used to specify the file name with which this record is associated. You do not have to repeat the file name entry on subsequent record format specifications for the same file. Position 15 is used to identify the type of line being described. Either we use the RPG fixed logic to generate the report, or we can explicitly write the records from our program. When we want to write the records explicitly, the record format line are called exception lines and are identified by an E. Positions 32 to 37 are used to provide the exception name. Using exception names allows you to control the printing without using indicators. Also, lines that need to be printed together in a group can be given the same name. Here, we have two lines that are to be printed at the top of each page. We give them both the same name, header. The third line, which will be printed for each record from the input file, we will call detail. Positions 17 to 22 are used to specify the spaces and skip entries. These entries are used to position a line of record in the report. Space is like hitting the return key. It causes the printer to head to advance a certain number of lines. You can specify 0, 1, 2 or 3. Also, you can specify whether the positionings has to be done before or after a particular line is printed. Column 17 is used for space before entry and column 18 for space after. Column 19 and 20 are for skip before and skip after entries respectively. We use skip when we want to specify a particular line number to which you want the printer to move. Skip 20 before printing causes the printer to advance to the line number 20 before the report line is printed. Skip after causes the printing of the current record to be done first and then the printer moves to the specified line. Next, we describe the contents of each line of the report through a series of field description entries. Positions 32 to 37 are used to specify the field names of the fields to be included in the report. In this column, we can also specify certain RPG 400 reserved words such as PAGE, which automatically provides the correct page numbers for a report. Another reserved word is UDATE, a 6-byte numeric field that stores the current date format. As you can see, our report also contains some constant text such as the column headings, page number, date. All these constants are entered in column 45 to 70 of the output specifications. They should be enclosed in apostrophes. Make sure that the left apostrophe is in column 45. For each of the fields and constants that we want to print, we specify the position at which we want the last character of the field or constant to appear. Lastly, we have the edit codes. Numeric and date fields can be formatted before being displayed so that is more readable. For example, an edit code Y causes date field to be printed in the format MMDDYY. To suppress leading non-significant zeros in numeric integer field, we use edit code Z. Be careful with decimal fields as it does not print the decimal point or negative sign. Totally, a set of 18 edit codes are available: 1 to 5, A to D, J to Q, and Y and Z. The edit codes 1 to 4, A to D, and J to Q cover all possible combinations of using commas, sign, and zero balances. Here is a chart of the edit codes. In case none of the available codes meet your requirement, you can always create your own template using edit word keyword. The number to be displayed will be inserted into the template and then displayed. Edit codes and edit words cannot be used together for the same field or constant. This completes the output specifications and the program. Let us move on to the RPG operation codes used for processing files. In this section, we will look at the RPG operation codes for file processing. We will see how to read, update, and write records in a database file, and also see how to position the database file cursor. One important point to remember here is how the data can be accessed. With program described files, we use the file name, whereas in the case of externally described files, we can use either the file name or the record format name. Let us first see how to position the file pointer to the required record in the file. We have the set lower limit operation that positions the file cursor to the first record whose value is equal to or greater than the value specified in factor 1. In factor 2, we can specify a file name or a record format name. When we specify a record format name, the file pointer is positioned at the first record of that format which has a key value equal to or greater than the value specified in factor 1. A logical file could have multiple record formats. Remember, the setLL operation only positions the file cursor. It does not retrieve a record. With the setLL operation, an indicator, if used in column 58 and 59, will be set on if a record is found in the file whose key value matches exactly with the value in factor 1. An indicator, if coded in columns 54 and 55, will be set on if value in factor 1. is greater than the highest key value in the file. An indicator, if coded in positions 56 and 57, will be set on if an error occurs on the setLL operation. However, it is not mandatory to use an indicator in any of the positions. Set LL in addition to the positioning the file cursor at a particular record in the file can also be used to reposition the file cursor to the beginning of the file by using the figurative constant star LOVAL in factor 1. SetLL can also be used to check for the existence of a record when used with an indicator in columns 58 and 59. Remember, when processing with a key value, the F specifications for the file should contain a K in column 31 to indicate that we will be processing the file using key values. To retrieve a record into the program, we normally use the read operation. The read operation will retrieve the next sequential record in the file to which the file cursor is pointing. If factor2 contains a file name, the next sequential record in file will be read, whereas if factor2 contains a record format name, the next sequential record of that format will be retrieved. An indicator in columns 58 and 59 is required for the read operation. It is set on when an end of file condition occurs and a record is not read. As with other file operations, an indicator in positions 56 and 57 indicates an error on the read operation. Another operation that is used to retrieve records into a program is the ReadEqual key. Let us see how this works. The ReadEqual key operation retrieves the next sequential record if the key value of the record matches the entry in factor 1. Factor 1 can be a field, literal, figurative constant. Factor 2 can be a file name or record format name. An indicator is required in positions 58 and 59 and will be set on if the key does not match the entry in factor 1 or if an end of file condition occurs. An indicator in positions 56 and 57 can be used to signal an error. You can also omit factor 1 if the file cursor has been positioned using setLL, SetGT, read or readE operations. These operations can be used within a loop to process a set of records with duplicate key values. You can use a setLL operation to position the file cursor to the first record in the group and then use the read E operation to process the records with key value equal to that specified by the setLL operation. As you may have noticed, the setLL operation requires processing by key. The SetGT operation is almost similar to the setLL operation. It positions the file cursor to the record whose key value is greater than the value in factor 1. Factor 1 can be a field, a literal or a figurative constant. Factor 2 can be a file name or record format name. As with setLL, setGT also does not require any indicators to be coded. However, you can code indicators in positions 54, 55 and 56, 57. The indicator coded in positions 54, 55 will be set on if the setGT operation is not successful. In this case, the file cursor will be positioned at the end of the file. The indicator in positions 56 and 57 will be set on if any error occurs on the setGT operation. An indicator in positions 58 and 59 is not valid. The setGT operation is used with *HIVAL to position the file cursor to the end of the file. As with setLL, setGT only positions the file cursor. It does not retrieve any records. To read a record so that it is available for processing, we use the read operation after setting the file cursor. Another operations that we can use to retrieve the records is the ReadPriorRecord. The ReadPriorRecord operation is similar to the read operation except that it reads backwards through the file. Here, the factor 1 entry is not used. The factor 2 entry is necessary and can be a file name or record format name. An entry is required in positions 58, 59 and is set on when the beginning of the file is reached. An indicator is used in positions 56, 57 and is used for signaling errors. You also have the ReadPriorEqual operation, which is similar to the ReadEqual operation, except that the ReadPriorEqual operation reads backwards. As with the ReadEqual operation, factor 1 is optional. If it is present, the key field value of the record being read is compared with the entry in factor 1. Otherwise, the key value that has been specified in the previous operation that has been used to position the file cursor. An indicator is required in positions 58, 59. It is set to 1 if the key value of the prior sequential record does not match the value in factor 1. As with the other operations, An indicator is used in position 56, 57 to signal an error. The operations we saw until now were used to retrieve records sequentially from the file. The chain operations can be used to retrieve records randomly from the file. An entry is required in factor 1 that contains the key value of the record to be read. It can be a literal or a field name. An entry is also required in factor 2 and it can be the file name or the record format name. An indicator is required in positions 54, 55. It is set to 1 if the chain operation is unsuccessful, that is, if the record in the file do not have a key value that matches the entry in factor 1. Also, an indicator can be coded in positions 56, 57 to signal any error. In the case of a file having duplicate keys, the chain operation will retrieve the first record that matches. If the chain operation is successful, the file pointer will be positioned at the record immediately from the record that was retrieved. Let us see how composite keys are handled in RPG 400. When the records in the file being accessed are keyed on more than one field, we must indicate the same composite value in factor 1. This is achieved through the k-list and k-field operations. In factor 1, we specify a name for the k-list. The k-list operation must be followed by at least one k-field operation. Each k-field entry identifies a field that is to be part of the composite key. The fields are concatenated together to form the k-list in the same order in which they are listed. Here, C-list is the key list name. It stores the combined value of customer ID and order ID. This k-list is used to chain to the order file. The k fields have different names from that used in the database file. However, the length, data type and decimal positions of each k field must match that of the corresponding key field in the database file. That is, the first k list field must match the first field of the composite key and so on. We can also use the k-list operation to create a partial k-list. The partial key should include the high order field or fields from the composite key used in the database file. For example, if a database file is key on customer ID, item code and delivery date, you can have a partial key list comprising of either customer ID or customer ID and item code. Let us move on to the output operations that can be performed on database files. First of all, on the F specifications, we specify an O in column 15 for output. We specify a K in column 31 if the file is to be accessed via a key in positions 40, 46. We specify disk for the device specification. Also, in addition to this, if we are adding records to the file and A is required in position 66 of the file specification. There are two RPG operations that allow you to output records to a file write and exCpt. The write operations requires a record format name in factor 2. It causes the current values of all the fields in the record to be written to the database file. An indicator can be coded in positions 56, 57 to signal an error. The other operations that we can use is exCpt. The exCpt operation on database files is identical to that used with printer files, which we have seen earlier. Factor 2 can include an E-line name that exists on the output specification. When the exCpt operation is executed, the program writes to the output file all the named E-lines if there is an entry in factor 2, or all the unnamed E-lines if factor 2 is blank from the output specifications. On the output specification, column 714 should contain record format of the externally described file. This is followed by a list of all the fields comprising the record or a value of star all to include all fields. If a field is omitted from the list, a value of zeros or blanks will be written to the record for that field depending on the data type of the field. To add record to a file, you need to have an ADD entry in positions 16, 18 of the output specification. This in addition to the A in the positions 66 of the file specifications. Two other operations that are used for working with database files are the update and delete operations. These operations can only be used for files designated as update on the F specification by specifying U in position 15. Here also, if you want to add records to file, an A should be entered in position 66. The update operation is used to modify the most recently retrieved record. It causes the current values of all the fields to be written to the file. Factor 1 is not used. Factor 2 should contain a record format name for externally described files and cannot be a file name. If you do not wish to update all the fields in the file, you can use exCpt operation to perform an update. The delete operation is used to delete a single record from a file. Factor 2 should contain the file name, or in the case of externally described files, it can also be a record format name. If factor 2 is left blank, the system deletes the most recently read record. When an entry is specified in factor 1, an indicator is required in columns 54-55 that will be set on if the record to be deleted is not found. An indicator can be used in column 56-57 to signal error conditions. With this, we have come to the end of this chapter on database files. Summary. In this chapter, we saw how database files are handled in RPG 400. We have studied a sample program that used program described files.